Hi everyone, this is Nothing's Obvious series. This series is created to help you to understand something in the book that is usually written in the books as it is obvious to see that this is easy to show that something like that. So in this clip we'll talk about invariants. For example, let's imagine that we have a vectors in two-dimensional space. And how can we represent these vectors? One just said that, oh, we just put it in a coordinate system called the Cartesian coordinate with a basis b, which contain ex and ey. So we can write v in terms of the linear combination to be Vx Ex plus Vy Ey, where Ex and Ey are called components of V in the basis B. Um, if one say that, oh, why do we have to choose the Cartesian coordinate? Can it be another coordinate systems? Okay, they say yes. For example, we have the orbit coordinate with a basis B prime, E psi and E eta. So we just do the same thing by writing V in terms of the linear combination, which is V psi E psi plus V eta E eta. And of course, obviously, the components in the psi eta coordinates and the xy coordinates are not the same. So, and how can it relate to each other? Okay, one may ask that. We can associate the component vectors as this metric called the transition metric or change of basis metric. Okay, and so the components in the xy coordinate system can be mapped to the new coordinate system psi eta as this formula. So, and how about the magnitude of v? In the Cartesian coordinate, we can calculate the magnitude of V by the inner product or the dot product, which is in this form. Or we can view in the geometry point of view, we can see that it is just the Pythagorean formula. So how about the magnitude of V in the psi eta coordinate? We can see that this one is like the a little bit more complicated form compared to the xy coordinate. So how about this one? If we have to change the coordinate into the non-orthogonal basis, and how can it be possible to write the magnitude of v in terms of something similar to those in the xy coordinate or in the Cartesian coordinate? Even if the new coordinate that we changed is not orthogonal or orthonormal basis. Okay, this kind of question is very challenging. So we have to consider V in a different way. So instead of represent V in terms of the V psi and V eta components, we just project V into the axis instead. So we can write them as the V psi star and V eta star, which is equal to this one Vx and cos theta Vx plus sin theta Vy. So we can write the components in the star coordinate to the Vx and Vy. And from this formula, we can write the component in the psi eta coordinates in terms of the xy coordinates as well. So let's consider this expression v psi times v psi star plus v eta times v eta stars. We can see that this one, the result is exactly the same thing as the in Cartesian coordinate, which is equal to vx squared plus vy squared. And even if this coordinate is not orthogonal, but we still can write the magnitudes of b in terms of the square of something, like in the Cartesian coordinate. So this one, the star coordinate, is become something important and something useful when dealing with the non-orthogonal basis. And because the magnitude of v should be invariance under change of coordinates, so we have to find a way to represent the magnitude of v in a simple and easy form, like in the Cartesian coordinate. And the something star will come to save the day. Okay.